check if the set H is a subspace of R3. Justify your answer. For a subspace, the first thing we want to check is if zero vector or the zero element is there. So we got 3s, and we know that 3s is 0 when s is 0, right? So this is 0 when s is 0, so this is also 0, and when we take s equals 0 we get -2, so we got 0 0 -2. Okay, so zero element, the zero vector in fact is not in H. Okay, zero vector is not in H. That means H is not a subspace of R3, because we have three components. We still subspace of R. No, not a subspace of R3. Okay. Now next question: is the following set a subspace of P2? P2 is a set of all polynomials at most degree 2. It's like a plus bt plus ct square, and a, b, c are real numbers. Okay, real numbers, not integers. Okay, that's P2. Now we want to see if this polynomials of this form a plus bt square, okay, is also a subspace. So we want to check if the zero element is there first. Okay, if we take a0 and b0, because we can vary a and b, there are two real numbers, so 0 0, that means 0 plus 0, zero element is there. Now we want to see if we add two types of these, a number plus a number t squared and another number plus another number t squared, do we still get this type of element? In that case, this will be closed under addition, and we're going to multiply by a real number, and it looks like this is a subspace. Let's show three things. Don't have to show the first types. I mean, the zero vector is in this collection, we don't have to show. So let's say two vectors. Okay, let u a plus bt square and v a plus bt square type. We can just say a1 b1 a2 b2, two elements. Okay, then what is their sum? If we add these two, then a1 a2, those are numbers we can collect in one place. b1 t squared, b2 t squared, we can collect b1 plus b2 and t squared. This is in fact, okay, a1 plus a2, we can just write some other number. We can write another number, t squared, and this is in fact of this type, a number plus another number t squared. So that is in fact there. Okay, so that's in the collection. And also let's multiply this u by a real number. Okay, if we have k times u, then that will be k times, where k is a real number, so for k in any real number, and these are also any vectors of this form, k times u is a1 plus b1 t squared. If we multiply, we just distribute k a1 plus k b1 t squared. K a1 is just a number, we can say, okay, another real number, I don't know, c1, and this one we can call d1 t squared, and this is also of this type, a number plus number t squared. Okay, that means this is closed under scalar multiplication. Okay, this one shows this collection of the form closed under vector addition. That means closed under scalar multiplication. Okay, so this collection is yes, so we can write yes, a subspace of P2. That collection is a subspace. Okay, now the last question here. Determine if the set H of the matrices of this form is a subspace of M22. M22 is vector space of all 2 by 2 matrices. Okay, so here let's see what we got here. A, B, 0, negative A, and A and B are real numbers. Okay, when they are integers only, then that's a different story, by the way. If we take A0 and B0, 0, 0, 0, negative 0, which is also 0, that means the 0 element is there. If we add these two types, do we get the same thing? It looks like it. Okay, so let's see. We can call H, right? So we take two elements here. Okay, let me correct this one. I wanted to erase this. Okay, so let U is just that. We can always take AB 0, negative A, and B, same thing, same type. AB 0, negative A are two elements. We can always call, they have to be different. A1, B1, A1, A1, B1, A1. Let this are coming from H. Then if we add these two, okay, then U plus V. If we add, it's going to be A1 plus A1. Sorry, this should be A2. My bad. This should be different. Okay, A1 plus A2 here, B1 plus B2, 0 plus 0 is 0, negative A1 minus A2. So negative A1 minus A2. I can pull negative out, so A1 plus A2. When these are from this structure, A negative of that. So A1 plus A2 negative of that. That means this is in this collection H. Okay, that means H is closed under addition. So next we want to show H is, so this means, this implies H is closed under vector addition. Now we want to take a real number and multiply U. Okay, so K from a real number, any real number, K times U will be, if we multiply by K, it's going to be KA1, KB1, 0, negative KA1, and which is also of this type. Okay, of this type. That means this is also in H. So H is closed under scalar multiplication. That means H is a subspace of M22.